Well, hello, welcome back to Parser Hacking. We are working on assignment in this video. Just pretty simple assignment. I'm not going to do like X and Y. Like you can do this in Ruby where you put more than one variable in parens and assign. I'm not going to worry about that right now. Just doing pretty simple assignment. I'm going to do variables, and if I get to it in this video, I'd like to do instance variables, class variables, globals, and constants. But just to get started, we would just want to do a very simple local variable assignment. So what will it take to do something like this? Let's just run our test and see what our error is, and it might give us a clue as to where to start. So first of all, we get syntax error unexpected identifier, and I think I know where that happens. It happens in the parser header, and right here, I believe this is the only place we produce this error, unexpected token. So we tried to grab a null denotation, and if you remember from previous videos, a null denotation is just an expression that stands alone. It doesn't require something on the left side. So we try to grab an expression using this null denotation function, and nothing gets returned. We return a null pointer. And so I think it might just be as simple as adding a new case to here that is for an identifier token. We're already lexing the input, and we get a token for that. And we just need to we need to do something with it. Now, what do we do? I don't think we can assume that it's an assignment, because later on we're going to need to be able to look up the identifier. So let's return a function pointer called parse identifier. It's going to do almost nothing at all, at least in the beginning. It's going to be a lot like this string. And we're going to do parse identifier. And we're not actually getting our expected output, are we? Could just turn it into a symbol. But I'm not sure that's going to work either. So this is supposed to return a node. Let's just go look at our nodes. Yeah, we can't return a symbol. We have to return a node. But it can be a symbol node. Where do we use that? Do we not use that at all anywhere? Let me just grep for that. Yeah, we don't actually use that. Interesting. Let's do that for now. I don't know that that is right. Yeah, that's not right. We need a new one. Sorry, I'm all over the place. Because later on we are going to have symbols, and that needs to return the right thing. So let's just make a new one called identifier node. Identifier node. It's going to take the name of it, const char name. We're going to say name is name. We're going to assert that we actually got a name pointer. To Ruby is just going to be a nil for now. And we'll leave a nice little fix me there. And this is going to be the name. And yeah, but not a value. Oscar. Okay, so now we have this identifier node. We want to create a new one here, and we want to just put the literal in there. We're going to have to dupe this. But hopefully, and this is not a symbol, this is identifier. Okay. So now we know how to parse the identifier. And so our error should change to unexpected equal sign, I believe. Yes, unexpected equal sign. So now, down here in our loop, where's our loop? Where is it? It's up here. Of course it is. Yes, parse expression. While it's valid and the precedence is less... Okay, so we need to be able to get precedence for a new token. And it's going to be in here somewhere. Let's just look up the precedence of assignment. I think it's going to be up somewhere around call. I just want to make sure. Ruby operator precedence. I'm not sure any of these sites are going to be great. Just want a list. Highest to lowest precedence. Okay. Unary plus and unary minus. Okay, we haven't done that yet. Equality is pretty high. Addition and subtraction is pretty high. And equal is way down there. Oh, right, because higher precedence happens first. Okay, I had this backwards. I always get this backwards. Yes, so plus and minus and all that stuff always happens first. And assignment happens way down here, right before the keywords. Interesting. So that didn't really answer my question of, is it... I think it's somewhere here. Let's just go with that for now. We can always rearrange these later. Assignment equals 6, and we'll redo that to 7 and 8. Yeah, I just realized I don't really need these to... I don't really need to number these explicitly, I don't think. But I'm not going to change it right now. I don't want to have two problems. I only want to deal with one problem at a time. But what if we do... oh, what is it called? I pulled the token header out, or the token struct out into its own header, by the way, which helps quite a bit when I'm looking around for stuff. Do I have an equal? Yeah, I just have a simple equal. Equal. And this is going to be assignment. Why does assignment look funny? It has two S's, right? Yes. Of course it does. So I'm going to actually add a little S there. Make sure we spell things correctly so we don't look like dummies. Don't want to look like a dummy. Okay, so now we get the precedence for assignment. Does that change our error in our test? Yes, it does. We got something. We got a call. That is certainly not what I expected. So it sort of treated this like a an infix operation. Infix, parse infix expression, left denotation. Yeah, because that's our only left denotation. Okay. We actually need to do a switch statement here. Switch On type, I'm just going to use this sort of same pattern here. And so, if it's a plus or a minus or a multiply or a divide, get precedence, plus, minus, multiply, divide, or equal. Okay, so if it's any of these, we want to return parse infix expression. If it's an equal, we want to return parse assignment. Otherwise, what do we want to do? Return a null pointer, I guess. And up here where we do left denotation, we need to sort of do the same thing where we check it. And if it's not something that we can use, then we raise a syntax error with the current token and its type value. Okay, I think that works. This isn't exactly right. It's getting closer. Parse assignment. So right below parse infix expression, I'm just going to copy this. Parse assignment expression. That's what I should have called it. Parse assignment expression. And we're going to, we don't care about the op. We'll just advance right past that. We want to get the right-hand side, parse expression, and the precedence is we'll just pass current token here to make sure we get the right precedence. I could hard code it. We know what it is, right? Assignment. And then we want to do an assignment node. And it's going to be the left and the right. So we need an assignment node. Just follow the squiggly lines. Actually, why don't I just stay over here? So I can have the same file open in two windows, and then I could go up to the top here. So we have call node, identifier node. I'm kind of doing them in alphabetical order. So let's copy this. Assignment node. We don't need the add node. Don't know about the Ruby stuff yet. So let's just return env nil obj for now. Fix me. We're going to say, let's car name. Let's see, member name and value. Kind of like left and right, but we'll do name and value for now. I think it might be a little more clear. I'm going to steal this code. Assignment node, I'm going to say, actually, so the, we don't want these to be const char. That doesn't make sense. Node. Okay, name and value is still fine. Name. Okay, where was I? Value, this is going to be a node. Okay. Oops. Name, value, name, value. Okay, I think we got it all. So now we have an assignment node, which points to a name and a value. Should I make it left and right? No, let's just make it name and value. That's fine. Okay, assignment node returns a new assignment node. Parse assignment expression. What can this return, this parse expression? It can raise an error. Well, what if there's nothing there? What happens? Skips new lines. Yeah, I'm not sure. I'm not sure what happens if there's nothing after the equal sign. What happens to our parser? But that's okay. Let's just run our tests and see what breaks. Well, we got a nil. All assign x. Oh, but I know why we got a nil. Because of those fix me's. Okay, so the question is which one, right? It's probably this one. Which, it'd be kind of fun. Is in this other fix me, which I don't think we need just yet. If we did a new string value, env fix me identifier node to Ruby, something like that. That way we know exactly where that is. And this one we're going to fix right now. So what we want it to look like is this lassign followed by the name. We can work on that. So let's just do return new array. And we're going to put it down here. The first item in the array is a new symbol, which is lassign with no I. Yep. Okay. Followed by the name as a symbol. Name. Okay, but that means our identifier needs a way to get the name out. Our identifier node. So we need a constcar name, return name. Jump back to where we were. It's going to be name dot, is it called name? Yeah, it's going to be name. Is that weird? Yeah, I'm going with it. It's a pointer though. Okay, what? Use of undeclared identifier name. I disagree. Okay, well, let's save this and figure out. Okay, now it's happy. No member named name in node. That's because name is not just a regular node. It's a identifier node. Does that fix that? Unknown type name identifier node. So we need to kind of declare that identifier node. Can I do it like that? Name cannot initialize a member subobject of type identifier node pointer with an L value of type node pointer. Okay. Fair enough. Where do we create this? It's over here. Left. Well, I know this is an identifier node. It has to be. So, I wonder if I should have some sort of assertion here. I'm just going to go with that for now. Does that get us close? Why are you unhappy? Why are you unhappy? Invalid conversion from node pointer to identifier node pointer. Well, 37. Oh, identifier node. And what are you unhappy about? env. Okay. Now are we getting closer? L-assign x. Yes, we're getting closer. Now we just need to put the value in there. Well, that shouldn't be too hard. So it's just m value to Ruby, I believe. Boom. Awesome. Awesome, 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 awesome. I'm not going to do that yet. In fact, I got to get out of here, so I'm just going to wrap up the video right now and be done for this moment, but I'll come back and we can work on the rest of these in the next video. But yeah, wasn't too bad. Let's just kind of review what we did here. We created a new assignment node. We created a new identifier node, which we will make a little bit more use of later. I do like this returning this string value of fix me. That way when something fails in the tests, I'll know exactly what is failing instead of just getting a nil. That's nice. We had to add a new precedence level for assignment. Probably should have tested that. In fact, let's just go do that. We, of course, have to return the precedence when we're asked what it is. We added a new syntax error for when the when there's no left denotation found. Parse an identifier, parse assignment expression. It's all pretty simple stuff. Just kind of had to put a lot of boilerplate in different places. Oh, and we taught our left denotation function how to return the right thing. It was always returning parse infix, but now it can determine based on the operator what we're actually doing. And of course we added some tests and I just moved some stuff around. Okay, so that's good. But I did want to test, how can I test that? What I don't want this to think is this, right? We don't want that. So let's run it with the Ruby parser first and copy this because we want to match it exactly. So it's going to be a call lit plus lit2, lit1 plus lit2. And we'll run it through our parser and hopefully get the same result. Get the same result. Nope, did not get the same result. We got something different. You know, we got exactly what I was afraid of. We got the assignment is the left argument of the call to plus. Well, what did I do wrong? I put the precedence in the wrong order again. Assignment is a lower precedence. And I know why, because when I was looking at this page, where'd it go? These are highest to lowest, whereas my thing is lowest to highest. So I think it's here. When we actually get equality checking, we'll be able to verify that. But does that fix the precedence? Boom, it does. Okay, so now that we got a green test, I'm going to do some refactoring. I'm going to get rid of all these numbers here because they, just let the compiler do it. there's no reason for me to manually do that. Make sure nothing broke. Let's do this. Okay, so I'm going to do parse a simple variable, let's see, local variable assignment expression. And call it good for this video. So thanks for hanging out, and I'm continuing on my walk through December, one video a day if I can do it. If I can find the time, I'm gonna keep recording, and obviously you don't feel obligated to watch all of them. It's really for me and staying disciplined and churning out a little bit of progress every day. And so I encourage you to do the same. If you have a project that you want to work on, just put a little bit of effort into it every day, and you'll make some progress in no time. But anyway, thanks for hanging out and encouraging me and my project, and I will see you next time.